Let's take a look at a question on the topic of circle. If you are given an equation of a circle, how do we determine whether x-axis and y-axis are tangent to the circle? I'm going to show you two methods here. Method number one, I'm going to write down what are the vertical and the horizontal tangents to the circle. Now notice that if I know the center of circle and I know the radius, so I will be able to find the vertical and the horizontal tangent by a very simple method over here. So let me just draw the diagram out for you to see. So it looks something like this one here. If I have the center of circle and I know the radius, I can easily find out what are the horizontal and the vertical tangents. So let us work on the equation first. I'm given x squared minus 6x plus y squared plus 10y equals to 66. Let me complete the square here. Okay, and let me write down the equation of circle so that I can see what is the center and also radius of circle. I'm going to move these two over there, so I get 100. Okay, next task, let me write down the center of circle. In this case, will be 3, 95, and the radius will be square root of 100, which will give us 10. Now, let's take a look at the vertical and the horizontal tangent. I'm going to first use the x-coordinate 3, moving 10 units to the right and 10 units to the left. So, making use of this x-coordinate, x equals to 3, moving means plus 10. So this line here, the equation will be x equals to 13. And if I minus 10, 3 minus 10, this line here will be negative 7. So I'm going to make use of the same technique. Let me look at the y coordinate now, which is negative 5. So let me write down here, y equal to negative 5. I'm going to use the same technique. If I go up, means I add 10. Minus 5 plus 10, this line here will be y equals to 5, okay? So let me go down now. Negative 5 minus 10, this line here will be y equal negative 15. So take a look at the picture here. Once I know the center, I can find the horizontal tangent and also the vertical tangent using this very simple method. So I'm going to list down what are the vertical and horizontal tangent. So I have 4 equations here, and none of them are x and y axis equation. So I can conclude that x-axis and y-axis are not the tangents. So this one is the method 1 of answering this question, part 1 of this question. I'm going to erase this and show you another method. Now let's take a look at method number 2 here. I'm still going to make use of center of circle and also radius. What I'm going to do is I'm going to plot the coordinate axis. I'm going to place 3 and negative 5 in here. So 3 and negative 5 roughly here. Let's discuss the shortest distance to both the axes. So you notice this one here is 5 units. And this one here is 3 units. So shortest distance from center to the x-axis here is going to be 5 units. And to the y-axis here, it's going to be 3 units. And you notice that the shortest distance to both axes are both not equal to radius. So I'm going to write shortest distance to both axes are not equal to radius of circle. And therefore, x-axis and y-axis cannot be the tangent to the circle because the distance are not equal to the radius. Now let's take a look at part 2 of the question. Does the point 2, negative 4 lie inside, on or outside of C1? Now let me call this point here P. We have 2, negative 4. And the situation is that if I have a circle with a center C, P point can be inside, on the circle, or outside the circle. So what we're going to do is to check the distance to this point P here. Okay, so if it's directly on the circle, the distance will be exactly equals to radius r. So I'm going to do a distance from P to C. So let me calculate this value here. So this one will be square root of 2. So we notice that square root 2 is less than 10, which also means distance from the point to center is less than radius of circle. So therefore, the point lies inside of circle. Okay, so when you have this situation that's inside, the distance will be less than r. What is on the circle, it will be equal to r, and when it's outside, d will be more than r. There are the three cases that you should consider. Now let's take a look at part 3 of the question. A second circle C2 is the reflection of C1 on the y-axis. Find the equation of C2. Now when we are doing a reflection of the circle, what you need to notice is that the radius remains unchanged. So I'm going to use back this number 10. What we're going to change is this one here. Let me draw the y-axis. 395, it will be on the right hand side. So when you reflect this point C, what you see is that you reflect over to the left hand side. So this one here, let me label C prime. This value here from 3 will change to negative 3. Notice that the y value will remain the same. You'll be at the same height here, okay? So what changes is only the x coordinate in this situation. So let me make use of the new center of circle, which is this one here. Pairing with the same radius, let's write an equation of a circle now. So I'll get x plus 3 squared plus y plus 5 squared equals to radius squared, which is 100. That's all for this question here on circle.